not audible. Yeah. Okay. Hi everyone, I'm Yacov Manevich and I work at Ava Labs, and what I mostly do is consensus protocols, and also I dabble with the core, with the Avalanche core. And what I'm going to talk with you today is three things. So first of all, I'm going to explain to you what Simplex even is, because I'm going to talk about Simplex consensus. Also, I'm going to show you a short demo of Simplex consensus in action integrated into Avalanche Go. And also I'm going to talk about how Simplex consensus fits into the Avalanche roadmap and show you some, and talk about really cool future features. So first of all, I need to make a small disclaimer. The Simplex consensus is a paper which was not authored by Ava Labs. It was authored by two researchers from Cornell, Benjamin Chen and Raphael Pass, and we just use it because it really fits our needs really well. So unlike Snowman and all of these sub-protocols that a Snowman consists of, Simplex is a classical consensus protocol that is based on voting. So unlike Snowman, where you have nodes reaching out to other nodes and polling for what they think about different blocks, in Simplex, nodes just vote, and they broadcast their votes everywhere and to all other nodes. The protocol proceeds in rounds. Each round corresponds to a single block. And also each round has a designated leader, or you can call it also a block proposer. It's also very crucial in Simplex that the leader role frequently changes, because we use it to ensure censorship resistance. So how does Simplex work? Essentially, we have in each round a leader node, right, a block proposer. So this leader node or block proposer builds a block, then it broadcasts this block to all the other nodes. Then, once a node receives a block from the leader, it broadcasts a signed vote message. It signs on the block and broadcasts this vote. Now, we say that if a node collects votes from what we call a Byzantine majority, which is above 2/3 of the nodes, such a block is then considered notarized for that node. And once a node notarizes a block, it can move to the next round. And in the next round, usually there will be a new leader. However, this block is not yet part of the blockchain. It's only notarized. And in order to make this block part of the blockchain, we need another step, and this step starts whenever a node notarizes a block. It sends something we call a finalization message. And as in the previous case, as in the notarization case, when a node collects a Byzantine majority of such signed finalization messages, then this block is considered as finalized, and it becomes part of the blockchain. So I talked about a leader. However, what happens if the leader crashes, right? If the leader crashes, we need some way to make progress, so we need to move to the next round somehow. So what we do in Simplex is when the nodes detect that a leader is faulty, usually there is some kind of timeout. After this timeout, the nodes lose their patience, and they start notarizing something which can be called a no-op block. It's essentially something like a block, but it doesn't have any transactions, and the only goal of this block is just to move the nodes to the next round. Hopefully in the next round there will be a functioning leader that hasn't crashed. So now when we understand how Simplex works, it's time to actually show it in action. So here I have a custom build of Simplex protocol integrated into the Avalanche Go. So what I'm going to do now is I'm going to run a few nodes. This script just runs a few Simplex nodes, and these are Avalanche Go binaries, and I have 5 nodes, and the next thing I'm going to do is I'm going to create a chain. So I'm going to create a chain because we have the P, X, and C chain. They just run regular Snowman, but now I'm going to create a chain that would be used by Simplex, but just a second, I don't know why the screen is black. Okay. Just a second. Seems there's some kind of problem with my screen sharing. let me try to just reconnect this thing. I know why it's not connecting.
Is this a different app?
Yes, so what?
Never mind, stay.
Let me just continue with the presentation in the meantime, and then I hopefully will be able to show the demo later. So, assuming we saw this in this demo in action, so how does Simplex actually fit into the Avalanche Go roadmap? So, Simplex is going to be used only for L1s, not for the mainnet. So, in future L1s would be able to upgrade from Snowman protocol to Simplex protocol. However, that's not everything, because we also have two very important features that are pretty useful for L1s that are going to run Simplex. These two features are on-chain randomness and encrypted mempool. However, in order to create these features, we also need gradually to build some kind of building blocks. So the first building block that we're going to need is a building block called the distributed key generation, or in short, DKG. So what is a DKG? You can think of a DKG as some kind of magical functionality in which nodes send just randomness to this functionality. And then the functionality outputs back to these nodes keys. So each node receives a key. And then these keys, while they are random, they also have this unique property where it is possible to construct a single key, which we can call it a threshold key. And for example, a signature from this threshold key is equivalent to a signature from different sets of size 3 of the nodes in the L1. However, if we have only like a collaboration of less than 3 nodes, then it is not possible to reconstruct a signature or any other protocol output that we want. So we need like 3 or more collaboration of 3 or more nodes. Doesn't matter like which composition. Once we have a DKG, we can build something which we can call a threshold verifiable random function, a threshold VRF. So what is a VRF? In simple terms, it's a function that it can receive as input any string, even if the string is non-random, is completely predictable. However, the function would output a random string, and anyone can verify that this computation is done correctly. So that's why it's a verifiable random function. So if we have a verifiable random function, what can we do with it? We can have on-chain verifiable randomness, which is very useful for example, gaming or gambling. Last but not least, we have, if we have a DKG, we can build something called a threshold encryption. And what can we do with the threshold encryption? So we can have an encrypted mempool, which is very useful to protect against, for example, front running and other kinds of exploits. So essentially, transactions would be sent into the Avalanche Go nodes, and then the blocks are going to be finalized before anyone can see the content of these transactions. And then the content would only be revealed once the blocks are finalized. So that's it for today, and we'll be happy to take questions. And maybe probably after I can show you the demo, but let's take some questions for now.
Thank you. Just a quick question about the VRF. What do you use for the randomness?
We're going to use threshold BLS.
All right. Thank you.
Any other question?
As you mentioned that this consensus protocol Simplex will be used only for L1s. Why not for C-chain or other?
Yeah, that's a good question. So usually these consensus protocols, they don't scale that well when you have a very large amount of nodes. So in the mainnet, we have over 1,000 nodes. And that's where, that's like why Snowman and all the Avalanche family protocols are really good for a large number of nodes, because they scale really well, because you only need like to probe a logarithmic number of nodes. But as you see in the slides, in Simplex and also other like the classical consensus protocols, you send your message to everyone. Now imagine sending this message 1,000 times. It's very expensive.
Will this affect in some way the addition of nodes to an L1? Like, for instance, you have the churn rate.
So that's a good question. So the Simplex implementation will support what we call dynamic reconfiguration. So you will be able to dynamically add and remove nodes. If you go to the Avalanche Labs GitHub /S Simplex, you will see there a high-level design of how the configuration is going to work. Essentially, we will have some kind of epochs, and each epoch we have a static configuration, a static membership, and once the epoch changes, then the epoch changes once you add or remove a node. Yeah.
Any other question? I do have one quick one. Is it possible for a network that is scaling or growing to go from one consensus to another, or is that considered in the roadmap, like migrating consensus?
So hopefully you're not going to migrate consensus too many times, but what we are for sure going to add is a migration from Snowman to Simplex only for L1s, yes.
So for the migration, does the network halts?
That's a great question. I cannot answer you that because we're still not there yet, but we will make it in some way that you don't need some maintenance mode or a maintenance period. Yeah, it would be dynamic. So, I mean, starting from some block height, the network will simply transition to a new protocol.
Any last one? All good? Yeah.
An idea around what is the threshold to when it's convenient to transition to Simplex in comparison to Snowman?
You're saying like, are you asking basically which size of networks should you run Snowman and which size of networks should run Simplex? That's a fair question. I would say that for these kind of questions, usually you should do like performance benchmarking and also estimate the cost, because in Simplex you send the block to everyone, and also you send messages. So if you run it like on AWS, right, you pay for this, so you need to amortize the cost. It's not like I cannot give you an exact number.
Any last one? Real last? No? Oh, good. Perfect. Thank you so much, Yacov.